Mishcon Academy digital sessions.
First of all, welcome everyone to this Mishcon Academy session. My name is Rosanna Gray and I'll be hosting the session today along with my colleague Niall. I'm a junior consultant in the MDRxTECH team. Now, for those that don't know, MDRxTECH is the technology consulting and development arm of the Mishcon Group. We are helping clients use technology to transform their organizations. So today's topic of discussion is the dichotomy between using blockchain and the sustainability issue. Now, the carbon footprint of commonly used blockchain platforms is alarming, to put it straightly. For example, to put some numbers to this, in May this year, the Bitcoin blockchain was expending 132 terawatt hours on an annualized basis, which, to put a bit of a comparison, is the same as Sweden. But there is still a high interest in blockchain technology. Now, this is being driven by the recent price increases in cryptocurrencies, its transformative potential for businesses, as well as its increasing mainstream acceptance. But there's also a growing understanding of the imperative of decarbonization and ESG requirements, so environmental, social, and governance, among responsible organizations. These trends are currently pulling in opposite directions, creating ethical and sustainability concerns among environmentalists, but also among investors. Now, things are improving gradually. There are alternative players and mechanisms entering the blockchain market, as well as non-blockchain alternatives entirely. However, the high interest, the media attention, the investment, the celebrity endorsements, and not to mention the extremely volatile and worryingly influential Twitter account of Elon Musk, still focus on the most well-known platforms, i.e. Bitcoin, Ethereum, which are unfortunately also the least sustainable in their current state. So there's an education element to be played here to bridge the gap between organizations as well as governments, increasing emphasis on environmental and sustainability goals, clearly being demonstrated currently at COP26, and the high interest and investment in blockchain solutions. Properly implemented, the wider application of blockchain could actually be one of the biggest enablers of sustainability currently available, something which Sir David Attenborough has mentioned in his latest book, A Life on Our Planet. And it's also something that we are working on and seeing more and more of our MXT clients every single day working towards. So it's never been more important to truly understand what sustainable approaches are possible with blockchain if it is to achieve such scalability. So before kicking off with the discussion, I'd like to introduce our font of all knowledge today, Niall Roche. So Niall is my colleague in the MDRxTECH team. He is head of distributed systems engineering. He trained as a software engineer and has experience in CTO and advisory roles for advanced technology businesses. Niall is a prominent figure in the emerging technology ecosystem, specializing in data science and distributed ledger technologies, such as blockchain, as well as 5G and IoT systems. He has designed, developed, and implemented solutions in a variety of sectors, including construction, real estate, supply chain, legal, and sustainability. And notably, since joining the Mishcon Group, he worked with HM Land Registry to successfully complete the UK's first end-to-end digital transfer of real estate, and he continues to drive innovation in real estate contract automation with the Accord project. Niall, what is blockchain?
Yeah, blockchain is really a system for recording information across a network of computer systems. And the idea is that it makes those records secure, verified, and ideally immutable, so can't be changed over time. These are distributed systems, so the ledger is spread out between a network of computers. And it's decentralized because there's no real central node or anybody controlling the network. The idea is that each node keeps the other one honest, and they could all store multiple copies of the same data. So if any one of them goes down, the others can continue in the network. So blockchain can be seen as a little bit of duplication of effort compared to other systems, but it does make it quite nimble and fast to establish, because instead of having to build an entire network infrastructure and databases, you can use the existing blockchains that are there. The way that the network is stored internally is what makes these blockchains a little bit different in their implementation. The idea is that it links transactions in forms of batches called blocks, and each of these blocks is related to another block and a block that came before it, and so on. So you can see the entire history of a set of transactions right from the beginning up until the latest version, and you can validate at all points as to the state of the world that it's representing. And the way that these systems interact with each other and agree the state of the world is known as a consensus mechanism. And these consensus mechanisms are the ones that cause some of the issues in the way that they work in terms of energy consumption.
Why are some blockchains worse for the environment than others? You know, we hear all the time about Bitcoin and its use of proof of work consensus mechanism that you've just mentioned. Can you explain a bit about what is this and why does it bring with it such a large carbon footprint?
Well, that's because there are many different types of blockchain. So just to break it down a little bit, let's get some of the terminology right. So this kind of concentric circle model, I use the term DLT for many specific types of what people would consider blockchains. So distributed ledger technologies are really an extension beyond just having multiple databases. The traditional model of multiple databases has been around for many years, and that's great when everybody trusts each other. And one transaction will be replicated multiple times. Everybody presumes that that transaction is fair and there's nobody trying to really manipulate the network. Where it starts to get more useful for blockchains or distributed ledger technologies is around what happens when there's not as much trust. If there's a bad actor in there, somebody malicious who wants to actually take control of the network or maybe try and shout over the number of nodes that are there and make their voice heard and manipulate the transactions accordingly. So with the distributed ledger technology is an umbrella term for multiple ways of achieving that shared state. A blockchain is one way of doing that, is one technology approach, which is, as I mentioned, one block of data refers to another block of data, and so on, until everybody or all of the nodes on the network effectively store a single copy of that ledger. With distributed ledger technologies, you have a bit more flexibility. There are other approaches using graphs and DAGs and tangles and other things that we needn't get into, funny names like that, around basically where parts of the network will maintain a record of part of the network. So it's no one node that would have a record for everything. And that generally makes them a little bit more flexible, makes them faster to execute. They can have more transaction throughput than a traditional blockchain. So there are some subtle differences in the implementation of it. And then within the blockchain itself, there are permissioned and non-permissioned blockchains. So as I mentioned, where you might have a consortium of companies that trust each other largely, and they just want to make sure that the process runs efficiently, you might have a closed network. So you just need that piece of the network to communicate with each other, not necessarily in a public format, or you might have certain types of data where you don't want to reflect that data in a public ledger and have everybody see it in the world. So it's about choosing the right type of blockchain for the right type of solution that you're working with. And then on top of that, obviously, there are multiple different considerations for how these work internally and the amount of network activity and computing power that's required in order to implement these. And that's really where that huge distinction comes between the different types of blockchains, the different types of consensus algorithms that keep those blockchains accurate and up to date and trusted. The reason it's energy intensive is in order to secure the network, each of these blocks has, which is found by a miner effectively, or some computing puzzle that needs to be solved, requires a massive amount of computing power. You've already mentioned some of the stats, but we shouldn't necessarily not look at the benefits from blockchain. So in many cases, blockchain can make things more efficient. If you look at the benefits of what can be gained from having a trust in a system where there are no trusted parties and having a ledger that survives a computer failure potentially inside an organization because it's distributed across many other organizations, resistance to tampering, interference from, let's say, governments or other bodies that may choose to want to change the record, for example, you have to look at it in the round. How else can we do it? Well, I mentioned proof of work being the kind of evil one that gets all of the headlines around trying to be quite energy intensive, but there are other alternatives. So proof of stake is the main alternative, far less energy intensive way of doing things. So the miners do this for economic gain. In a proof of work system, it doesn't require energy consumption. It's really securing the network based on how much money somebody is willing to put in. So the idea is to try and stake your money, that you have corrected the right state of the world in the same way as you would if it was proof of work, and you arrive at the same result, and others will check that and say, yes, I saw these transactions as well. The order that you put them in is correct. We all agree. You get to keep your money and you get some reward as well. So that doesn't require a huge amount of computing power, same types of energy that would be required in traditional database systems as well. Now, there are arguments against that. There are arguments that that is not as safe, and it's open to economic abuse, that if somebody acquires enough money, then therefore they get to say what happens in the network. And again, there are many different approaches to ensure that that doesn't happen in different networks as well. So it's trying to ensure that there's no one center of control. The jury's still out on some of these things. There are some considerations. It's not a pure proof of stake is better than proof of work for certain types of things. And a large part of it is determined based on the economics and the crypto price. And will the miners or the stakers go and put their money somewhere else as a new chain comes around? And I think it's fair to look at the sustainability argument in regards to how sustainable is a blockchain itself as it will continue to develop.
And so you mentioned proof of stake as an alternative. So those looking to kind of first implement blockchain technology in their businesses, what are the other methods of kind of getting around that? So proof of stake is obviously an alternative consensus protocol. Other elements of where renewable energy could come into play? What are some examples of these platforms that are using these alternative methods?
Absolutely. So if you consider how a blockchain system works, it needs to maintain three particular aspects. It's known as the blockchain trilemma. It needs to be secure, and it needs to be scalable. It needs to be something that can compete with the likes of Visa, but it needs to be fit for purpose. And if more people are going to adopt it, therefore it's going to need to be a little bit faster. It's going to need to deal with those levels of transactions. It's still an early technology, so it is evolving. Distributed systems are not new. This is going back to the 70s and getting databases to talk to each other. So blockchain didn't start basically in 2008 from nothing. It was building on top of a lot of existing research. So the ability to reach consensus is not new. What has continued to develop is there are multiple different ways of doing it. Academics are starting to look at it. And the result of this academic and industry involvement is lots of different blockchain solutions. There are lots of different consensus algorithms. Can we build alternative ways of doing this that are trying to optimize for one or more of those corners of the triangle? Ethereum 2.0 is Ethereum's move away from the proof of work based method, which is not as computationally expensive as Bitcoin, but still is quite computationally expensive, and moving towards a proof of stake model as well. It's early days for it. It's been delayed. There's a lot of hype about it at the moment. Hopefully we'll get there. But within that, there are other proof of stake based and other non-proof of work, let's just say, alternatives that are out there that maybe are not as famous as the other ones, but definitely for businesses who are looking to consider what blockchain would I build on, it's worthwhile having a look at some of these names. There are some blockchains that are designed with scalability in mind. So being energy efficient is obviously a huge part of that because it allows them to scale massively. And as a byproduct of that, they can become less energy intensive.
What about those who already have implemented it? It may think, oh no, are we too late? And those listening red flags might be being raised and thinking, can we get around this? Are there ways of almost changing path to a more sustainable platform? What are the options for kind of people in those positions?
There are some immediate steps you can do. First of all, if you are running nodes yourself in your own infrastructure, you could consider moving some of those nodes over to a managed provider that can give you that supply offering and guarantee carbon offsets. You could look at porting to other chains, as I mentioned. Without getting too technical, there are some other options as well. So Bitcoin itself has a kind of side network called the Lightning Network. So the idea is we don't have to put everything and all transactions on the main chain. For smaller transactions, maybe lower value. So it's kind of like a light version of the blockchain, which then finally, once everybody's in agreement, there's not as many eyes on it, but it's far more faster, far more cheaper. And then if you want to record that transaction back on the public chains, you can do that at the end of the transaction or every X number of transactions. Again, you're scaling, you're trading off that security versus accuracy, and but again, that might be fine for certain cases. Can you re-architect and look again and upgrade smart contracts, which can happen in Ethereum, and try to look, well, did we do this right from the beginning? Is everything that is on chain, should that be on chain? Should we just have proof that an action has happened? It's never too late to consider moving to a different platform. And worst case, look at offsetting your own carbon contributions.
And I think those looking to digitally transform their businesses today will kind of immediately think of blockchain and think, okay, I have to use blockchain. for them, is the answer simply use proof of stake because we've heard that's the most sustainable, or are there perhaps other emerging technologies that could be a better solution?
From a sort of more permissioned perspective, so within a business doing business inside a network, they don't necessarily want to have the uncertainty of high transaction fees, for example. So gas fees on Ethereum being a major issue potentially. By using a permissionless approach, maybe that solves a number of their problems. It's like, oh, I didn't know we could have a kind of cut down version of a blockchain just for our sets of businesses that don't have gas fees, that have high scalability, and you don't have any of these issues. So I'd start with saying, does it absolutely need to be a blockchain or a distributed ledger? And then within that, would a permissioned one be okay? And then after that, if you find, no, we need a level of trust, we need it to be globally dispersed and ensure that we don't trust anybody in our group, then in that case, we start to look at a permissionless solution. And then, yeah, I think choosing one that you think will be around for a while and has that economic support, if it's proof of stake, because again, you don't want somebody coming in and buying the entire network. And for those that were still fearful, no, we think this is too early, then at the moment, unfortunately, proof of work is still the more secure game in town. But I think that is gradually starting to change.
With Bitcoin and Ethereum, they received so much hype so quickly before they had a chance to kind of mature and develop and to really achieve the kind of scalability goals that they wanted to. As
an industry, they're trying to improve best practice and say, okay, let's take sustainability seriously. And there's lots of things that we can't get away with, and we need to build for the future. Otherwise, people will vote with their feet. App developers may not want, or dApp developers, as they're known as in crypto world, don't necessarily want to build on one of these chains. And we've definitely seen a movement back away from some people who don't want to touch crypto investment or don't want to use blockchain at all, because they perceive that all blockchains are the same and they're evil and have a huge impact. So I think gradually the industry is starting to look at this and say, well, actually, hang on, we do have to treat this a little bit more seriously.
But I think it is clear that we can't afford to ignore blockchain's growing carbon footprint, especially as businesses, as well as on a global scale, we aim to meet that net zero sustainability goal. But there are things we can do about it, as Niall's taught us, while still harnessing the significant benefit. So thanks all for joining, and I hope you have a lovely rest of your afternoon. Thank you, Niall.
Thanks, Rosie.
The Mishcon Academy Digital Sessions. To access advice for businesses that is regularly updated, please visit mishcon.com.